So in this video we are gonna see some basic trigonometry that apply to the resolution of right angle triangles exercises. So there's three rules. They are very useful on this kind of exercise. So let's consider this generic triangle is a right angle triangle. So one angle is 90 degrees. The other two angles we can call them alpha and zeta. So the Pythagoras theorem says this is only apply for right angle triangles. The square of the hypotenuse is the longest side, they call A. So the sides called A, B, C. So the square of the hypotenuse is equal to the sum of the squares of the other two sides. So A square is equal B square plus C square. So this is Pythagoras theorem. It's very useful for this kind of exercise. The second one is the sum of angles of a triangle is always 180. That applies for all kind of angles. So in this case, we will say that 90 degrees plus alpha plus zeta equal 180 degrees. So from this we can simplify and say that alpha plus zeta equal 90 degrees. Also very useful. And the sine theorem. The sine theorem says that any side, for example A, over sine of the opposite A over sine of the opposite angle, so in this case sine of 90 degrees, is equal to another side, let's say C, over the sine of angle, the opposite angle. So C over sine of alpha in this case, and is equal to the other side, B over the sine of the opposite angle. It's easy to remember. So this law is very, very useful. So with these three rules, we can do many exercises. Let's see a few examples. Here, this triangle, we have one side 3, another side 4. The hypotenuse we don't know. And then, of course, one angle is 90 degrees. The other two is alpha and zeta, we don't know. So we need to calculate A, the side A, angle alpha and zeta. So this is, so let's see how these three rules apply here. The first one, Pythagoras. Okay, so we just write the equation. So the square of the hypotenuse, so A square equal sum of the square of the two other sides. So 3 square plus 4 square. So we can continue here saying that this is equal 9 plus 16, which is 25. So A square is equal 25. If we want to know A, we need to get rid of the square. So what we do is root square in both sides. So we will say root square, get rid. So we will say A equal 5, right? So we already got A. So now, sum of angles of the triangle is 180. So all we know here is that 90 plus alpha plus zeta is 180. And from this, that alpha plus zeta, 90. We cannot get more information. Okay, let's see, this is the second rule. Let's see the sine theorem, what we can get from this one. So let's take, for example, A, which is 5 over sine of 90. Sine of 90 is 1. you know, by definition, we will know, we will see later. It's equal any other side, let's say 3 over sine of alpha equal 4 over sine of zeta. Okay, so now we can get different equations. One can be, if we take this equation, no? So this is 5 over 1, which is sine of 90, equal 3 over sine of alpha. We can take to the other side of the equation sine of alpha, so we will say sine of alpha 5 times sine of alpha equal 3. So sine alpha equal 3 over 5. So 3, we can leave it like this, or we can just make the division. So 3 over 5 equal 0.6. So equal 0.6. So how much is alpha then? So alpha is an angle which sine is 0.6. So what angle is this one? So we need to find on the calculator the function arcsine, or sine, in some calculators, sine inverse sine 0.6. So we need to know what angle have sine, the value equal to 0.6. So we just go to the calculator and then we find inverse sine and 0.5, inverse sine 0.6, sorry, 0.6 equal 36.87. We can just round. So 36.87 degrees is the alpha angle. So we got already alpha, so now we need to find zeta. So zeta we can calculate with this equation now, because we already have alpha. But we can, maybe easier, just go to the second law and say alpha plus zeta has to be 90. So zeta is 90 minus alpha. So this is equal, go calculator. So 90 minus 53.13. So 53.13 degrees. So we have everything. So we got alpha as 36.87, zeta 53.13, and A 5. So another example, we have here, well, this is 90 degrees. So from Pythagoras theorem, we get that the hypotenuse, which is a square, equal to the square of the sum of the squares of the side of the other side. So equal 4 squared plus c squared. So from this we cannot get any solution yet, because we have only one equation and two variables. From the second law we get that 90 plus 30 plus alpha equal 180. So it means that alpha equal 180 minus 120, so 60 degrees. Right, so we got already 60 degrees. Alpha 60 degrees. Okay, so we go to the sine theorem. and then we can get, for example, a over sine 90, which is a over 1, so it's a, equal 4 over sine 30. So from this, we can get straight away the value of a. So a over 1, which is a, equal 4 over 0.5. Sine of, there is some remarkable angles that we should know the sine, cosine, like for example, sine of 90, sine 30, 60, 45, and a few more, okay? So this one is 0.5, this one is 1, this one is square root of 3 square root over 2, over 2, and this one is 2 square over 2. But anyway, we have also the calculator. So coming back to here, so a is 4 over 0.5, so it means that a equals 8. Right? So now we have a, we have 4, so we can calculate here c, but also we can use again the sine theorem. For example, we can say, okay, c over the sine of the opposite angle, in this case is 60, so c over sine of 60 equal a, which is over 1, which is 8, we said, no? So we can say 8 over 1. So c, from here we get that c is 8 times sine 60. So sine 60 equal times 8 equal 692. So c is 692. Okay, so we've got everything, alpha, a, and c. If you want to double check that everything is correct, we can see if the Pythagoras theorem verify. So this must be true, so that a squared, so 8 squared equal 4 squared plus c, which is 692 squared. So let's see, 692 squared, 92, 48, yeah. So we have 64 equal 16 plus 48, which is correct, yeah. So everything is all right. Another example. So we have the hypotenuse is 6, the angle, the acute angle is theta and 2 theta. So this is 90 degrees, and then we don't know a and b. So we don't know a, b, and theta. So using Pythagoras theorem, we get that 6 squared equal a squared plus b squared. So we cannot get anything from here, only that. With the second law, we get that 90 degrees plus theta plus 2 theta equal 180. So it means that 90 minus 3 theta equal 180. So 3 theta, sorry, plus. So 3 theta equal 90. So theta equal 30 degrees. So then this angle is 30 degrees and this angle is 60 degrees. And all the sum of all together is 180. And then we go to the sine theorem, and then we have that 6 over sine of 90 is 1 equal a over sine of 30, and also is equal b over sine of 60. Let's get, because here we know this, and this, so we only have, don't know a, so we get this equation. So 6 over 1 is 6 equal a over 0.5, which is sine of 30, right? So sine of 30, sine 30 equals 0.5, right? So a equal 0.5 times 6, which is 3. So a equal 3. Okay, so we only need find the value of b. So we can go to Pythagoras and find b here, or we can use the sine theorem, for example, with these two equations, these two. So we can say that a over sine of 30 is 6, because we already confirmed here. So 6 equal v over sine of 60. Sine of 60 is sine of 60, 0.87. So 0.87. So b equal 6 times 0.87, which is times 6 equal 5.2. So 5.2. So b equal 5.2. Sorry. So again, we can, if you want, you can double check and see that that is okay for Pythagoras theorem. So everything matches. Okay, so you can check. And well, this is everything. Okay, thank you very much.